Think long before the first pterosaur took flight, the sky was already ruled by monsters that flew by violently reshaping their own ribs. When you imagine the first creatures to conquer the atmosphere, you picture pterosaurs stretching leathery wings. Perhaps the delicate feathered ancestors of birds. You picture grace. You picture elegance. You picture wrong. 300 million years before any pterosaur drew breath, insects with wingspans of 2.3 feet were already apex predators of the air. And the vertebrates that beat pterosaurs to flight did not use arms. They flew by extending their own rib bones out of their bodies, skeletal struts fanning laterally from the spine like the deployable panels of a satellite. This is not evolution as you learned it. This is evolution's first draft. Violent. Unrefined. Written in an atmosphere so thick with oxygen it acted as a biological steroid, 35%, compared to the 21% you breathe today. An invisible accelerant pumping into every cell of every organism on the planet. So what happened to these designs? What cataclysm wiped them from the evolutionary record and forced nature to start over? To understand, you must look inside the chest cavity itself. You must see how a reptile could glide on its own exposed ribs. And you must meet the creatures that were hunting 40 million years before these reptiles even existed. Consider the Weigeltisauridae. A family of late Permian reptiles that achieved the first vertebrate aerial locomotion not through arms, not through membranes stretched between fingers, but through radical mutation of the thoracic skeleton itself. The ribs. Not as protective housing for organs. As wings. These bones extended laterally from the spine 40 inches across. 1 meter. The width of a standard doorway. They fanned outward like the deployable struts of a satellite solar array, stretching a membrane of skin into a rigid, skeletal kite. The creature did not flap. It launched from elevation and glided, its own ribcage serving as the primary flight surface. This is not aerodynamic elegance. This is brute force engineering. Evolution hijacking the skeletal core and repurposing it for a function it was never designed to serve. But as grotesque as flying on your own exposed ribs might seem, these reptiles were not the apex predators of their era. Something far worse had already been hunting for 40 million years before them. The Meganosoptera. Giant griffin flies. Biological attack drones with wingspans stretching 2.3 feet, the size of an eagle. Equipped not with talons, but with something far more efficient. Their legs. 6 of them. Each lined with rows of chitinous spikes. These were not limbs for walking. They were raptorial capture systems, a mid-air spike trap that locked shut around struggling prey like a medieval Iron Maiden. Once the cage closed, there was no escape. Only consumption. And they did not hunt other insects. They hunted vertebrates. Full-sized amphibians, snatched from the swamp floor and eaten alive mid-flight. The sound of this era was not birdsong. It was the heavy, thumping, low-frequency drone of 2.3-foot wingspans beating hyperdense air. More helicopter than insect. More weapon than animal. But here is the question that should disturb you. How could an insect grow this large? Insects do not have lungs. They breathe through spiracles, passive tubes in the exoskeleton that deliver oxygen directly to tissues. At modern oxygen levels, an insect this size would suffocate under its own weight. The tubes cannot supply enough fuel to a body that massive. The answer was in the air itself. At 35% atmospheric oxygen, every breath delivered 67% more biological fuel than modern air. The passive tube breathing system that limits insect size today could suddenly support bodies of monstrous scale. Hemolymph, not blood as you know it, but hydraulic fluid pumped through thoraxes the size of a human fist. Compound eyes spanning inches scanned the fog for the twitch of prey trying to hide. The atmosphere was not air. It was a hyperpotent biological accelerant. Nature's version of a performance-enhancing drug, injected into every living cell on the planet. The X-ray reveals the capture sequence. The griffinfly's muscular thorax contracts. The spiked legs thrust forward. As they strike the target, the joints hyperextend and lock into a rigid cage, obsidian black chitin, neon green hemolymph pulsing through pressurized vessels, metallic silver spines punching through amphibian flesh. The prey enters the kill zone. It does not exit. But a drug that powerful always has side effects. And the same atmosphere that created these apex predators was slowly building toward an apocalypse. The Carboniferous swamp was not an environment. It was a pressure cooker. Air so thick, wet, and oxygen-rich that a single breath would make a modern human dizzy. Hyperactive. Prone to oxygen toxicity, the same condition that poisons deep-sea divers who breathe pure oxygen too long. Your cells would burn fuel faster than they could manage. Your nervous system would misfire. The atmosphere itself would poison you. Through perpetual fog, the compound eyes of griffin flies scanned for movement. Not color. Not shape. Just the rapid twitching of prey trying to remain still. Vision optimized for the low-light swamp floor, where towering moss trees blocked what little sun penetrated the greenhouse haze. The scale of this era defies modern intuition. Predatory dragonflies the size of eagles. Gliding reptiles with wingspans matching doorways. In certain river deltas, giant insects accounted for 50% of the total biomass. Not a minority. Half of all animal weight in the ecosystem. For over 100 million years, these designs dominated. They were not evolutionary accidents. They were stable, successful blueprints, refined across deep time. The Devonian period saw the first insect wings. The Carboniferous saw them reach their apex. The Permian saw vertebrates finally enter the game with their exposed ribcage gliders. Then the climate betrayed them. The swamps that sustained this hyper-oxygenated atmosphere began to dry. And in a world where the air itself was 35% flammable, the dying forests did not simply rot. They burned. Massive wildfires swept across continents during the Carboniferous rainforest collapse. Entire ecosystems reduced to ash. What the fires did not kill, the Permian-Triassic extinction finished. The Great Dying. 98% of all life erased from the planet. Every giant griffin fly. Every rib-gliding reptile. Every monstrous Paleodictyoptera, those 1.8-foot herbivore insects that pierced ancient trees and drained their internal fluids like hydraulic extraction pumps vampirizing the forest. Deleted from the evolutionary code base. When pterosaurs finally took to the sky 230 million years ago, they were not pioneers. They were inheritors. Colonizing a graveyard that had been empty for 30 million years. You look at the skies today, filled with delicate birds and fragile butterflies, and assume this peaceful state is the rule of nature. It is not. It feels designed for an alien planet. Yet it existed here. On this earth. Under this sun. Proving that our planet's history contains biology stranger than any science fiction. Nature's first drafts of flight were not elegant. They were brutal. Evolution did not carefully design aerodynamics. It violently forced creatures into the air by mutating their ribs and pumping the atmosphere full of biological jet fuel. And now the question that should linger. If a mere 14% shift in atmospheric oxygen was all it took to turn a fly into an eagle-sized apex predator, if climate alone could unlock biomechanical nightmares written into ancient genetic code, then what dormant monsters remain encoded in modern DNA, waiting for the atmosphere to shift again? The griffin flies are gone. The rib gliders are gone. But the blueprints never fully disappear. They only wait.